Good evening, everyone. Melissa Raspberry here from the CS for All Teachers community that is managed and facilitated by the American Institute for Research. We are very excited to have you all here with us this evening for this terrific webinar that honestly came together very, very quickly just last week. As I was with Dan Garcia and some other great computer science education advocates in Denver at an NSFPI meeting. We know that you are busily getting ready to prepare your students for the AP CSP exam. It is amazing how much this course has spread and just how exciting it is for so many students across the country to have access to such a wonderful computer science course. So we're excited to be here with you tonight. A few caveats. I'm going to turn things over in just a moment to Dan Garcia, who he's invited a few of his friends along to help get you prepared for the exam, help get you and your students prepared, I should say. But just a few things. We do encourage you to join via your microphone or the call-in number, which I'll copy and paste again into the chat window there. It was on the main screen. You do not have to call in and you don't have to get connected orally. We do encourage it, though, because it's a great opportunity for you to ask questions. But Amy, I see you're having some audio issues. That's okay. If you just want to listen in, that is just fine. We can certainly, you can ask your question in the chat window and we can elevate that and make sure that it gets given voice to that. But again, we do ask that you mute your line or your microphone if you've called in or have connected with your mic. On the top toolbar, there's a black toolbar at the top. You'll see a phone icon, and there's a drop-down menu that says where it allows you to mute. I can mute for some of you, but not all, so we do ask that you take care of that. We understand that you're busy folks. Some of you on the West Coast maybe still be at school, so you have bells ringing or people coming in, or if you're at home, you may have kids or dogs, etc. We understand it, but it just helps to keep a minimum to that background noise if you can help mute yourself. I'll be here to provide some technical support in the background once I turn things over to Dan, and I'll be checking the window. You can send me a private message if you hover over my name in the chat window. It should give you an option to send me a direct message, or you can just put it into the regular chat window and I'll take a look at it there. We are recording this in case folks are unable to join us live, because I'm sure lots of people are probably going to want to be able to hear what Dan and others are sharing, so just know that it is being recorded. And so without further ado, I'm going to introduce Dan Garcia. Dan is a teaching professor at UC Berkeley. Dan, I picked one of my favorite photos when I was Google stalking you today. I love this picture of you. I especially love it that it's labeled as Dan Eyebrow. Like, I really appreciated the file name. He helped to co-design the Beauty and Joy of Computing with Brian Harvey and Tiffany Barnes. He's an experienced presenter at 60, the Special Interest Group for Computer Science Education, and he was recognized as ACM Distinguished Educator in 2012. I could have listed lots more things there because Dan's a super amazing guy, but he's also very, very entertaining, so I'm sure you're not only going to get educated, but you'll probably get a few laps in tonight too. So without further ado, I will turn things over to him and let him get started, and he'll take things from here. So how about it, Dan?
Thank you so much. I guess I'm going to be screen shared in a second. I want to make sure people can all hear me. Feel free to respond if the speakers are not. Melissa, maybe you're my feedback if people can hear. If you can hear me, Melissa, I'm assuming everybody else can hear me. So. Perfect.
I used my own best practice and muted myself.
Perfect.
So yeah,
That's
you're good.
Thank you so much, Melissa. What I wanted to do is...
The leader has disconnected. The conference will be terminated in 5 minutes.
Uh-oh. Leader has disconnected. The conference will be terminated in 5 minutes. Okay. Let's see. It's like Mission Impossible. The message will be different. Well, we'll hope we last more than 5 minutes. Welcome, everybody. I'm delighted to be here. I've been part of the CS family for quite a while. January, led a in 2008 there was a conference in Chicago, and others created hard to talk to folks. Great. I'll try to chug through, but it's okay. This came out of the desire to get successful students. It would be wonderful if the folks had enough students for principals. So Baker and I each individually created some resources for students. It would be great to share them. Also, they came up with the last webinar. To be able to, there might be some interesting. Oh, can't hear me. Okay. I'll stop.
Hi, everyone. My apologies about that. I had a technical issue on my end and was trying very fiercely to get dialed back in. Hopefully you can hear me now. So please give me a message in the chat window if all is sounding better. I was seeing your messages but trying to dial at the same time. Okay. Do apologize for that. So Dan, I'm going to let you get started again.
Sure.
Again, my apologies.
No worries, no worries. I was just saying how delighted I am to be here. Baker and I have independently created some resources, and just together we realized that it'd be useful to be able to share these. This came out of the last webinar where I called in and I was chatting with folks about a resource I created, and I wanted to at least be able to share that and demo that. So we created a living, breathing document. This is a Google Doc. It's tinyurl/CSP webinar April 15. I'll copy and paste this into this. Feel free to click on that and jump right into the document. At the bottom of it, let me just scroll to the bottom. Here are some resources we created. Here's the overview of what we're going to do for our agenda for today's conversation. So we're going to do an overview of the actual multiple choice exam. We're going to share some sources of questions. We just scattered. We tried to find as many sources of questions as we could so students could get practice at these things as possible. So resources that we created. We then did a kind of a brainstorm of vocabulary our students didn't know. I've been teaching this course at Berkeley since 2009, and we were a national pilot. So I've always, been running the same kind of course, same curriculum framework every year, and I noticed that my students every year have trouble with some words. So I kind of listed those vocabulary words that our local students have trouble, and maybe high school students also would have trouble. Tips for doing well, and we'll end with community resources. So that's the place at the bottom. If you've created any resources this is a fully rewrite document. That link will take you to write privileges on this document. So feel free to just add your name and add your resources here and add a link in the kind of same format we've done. So this is going to go really fast this hour. There's a lot to cover, so let's jump right in. So as an overview, I stole some of these from the CED, the course and exam description document, the purple book, which talks about there's an end of course exam on May 5th. Cinco de Mayo, so I know where I'm going to be after the exam, celebrating the success of all these wonderful students, hopefully getting 5s. So it's a 2-hour exam, unlike the APCSA, which is a 3-hour exam. It's paper and pencil, it's not on a computer, 74 multiple choice questions, and they come in 2 flavors. Single select multiple choice, which is there are 4 options and you choose one of them, and multiple select multiple choice, and that's where they choose 2 out of the 4. Then later in this document, they talk about the percentage of multiple choice questions. So as you're taking 74 questions, what's the percentage of each of the big ideas in these questions? And it's not like the first set is all big idea 1 and the next set is all big idea 2. It is the idea in general that the College Board tries to move the questions that are easier at the front and harder in the back. And they also try to cluster these 2 so people don't get confused. Because you can imagine if every other question is the wrong kind, you're spending a lot of cognitive load just remembering what you're supposed to be doing. So I think they try to, for the most part, put the single select at the front, multiple select in the back. And within those groups, they try to kind of go easier to harder, just in general, which is a nice way. We try to do that in our exams locally as well. So if you look at the way that big ideas are distributed, you'll see that the first big idea, creativity, is not at all tested on the multiple choice exam. So that's, that was a change. That wasn't always the case. And so that's nice to not have to worry about one thing you can focus on, perhaps big ideas 2 through 7. So big ideas 2 through 5, if you look at them, the numbers are about 20%. So it says about 1/5 each is going to be these big ideas, and the last 20% is kind of split between internet and global impact. So as your students are focusing their studying, you wouldn't say, hey, focus all your study on global impact. It's only really 10% of the exam. Okay, so this is just level setting for everybody in terms of what the questions may look like. In terms of sources of questions, yes,
hi everybody, this is Baker. I just wanted to jump in just to also set the stage.
Yeah, please.
On some of those algorithms questions, I'll ask Dan, how many algorithms questions pose themselves as code-based questions?
Oh, that's, I don't have that number.
I mean, I think the point I'm making is that if you were to look at the actual exam and stare at it, there's more than 20% of the questions are going to look like they have code in them. It's just that the purpose of the question is an algorithmic thing as opposed to a programming thing. Is that accurate?
That's actually an important point to make. If you look at the sample of questions, I hope that everybody on this call, if you're teaching CSP, you have access to the 74 questions that were handed to you from College Board. It's not a public document, so you only have it if you've been part of the CSP family and you've filled in all the forms. So one way to do that, Baker, is to just do an analysis of those 74 questions. I haven't done that. Maybe somebody can do that right now in real time. But there are questions that are coded to other things that are not just programming. Because sometimes code will be a small snippet, but really it's about an algorithm you're testing. It's not about maybe a function or a programming element. So sometimes things get coded at big idea 4, sometimes 5, sometimes even big idea 2 or 3 if there might be a code and you're talking about the abstraction and thinking about an ands and ors and some Boolean. It's not a lot of code, but it'd be talking really about the idea that you can abstract things as logical gates, and so maybe there's a little bit of code from the pseudocode reference sheet that's actually coded as big idea 2. So if you're looking for things in a Courier font, it's not going to be always coded to 5. Some of them will be coded to more than that. I don't actually have the number from the exam that's coming up, nor do I have the number from the sample exam. But you're right, there are some things that are coded differently than just 5. That's a good point. Thank you for bringing that up.
Well, you're in luck.
And by the way,
I do have a spreadsheet that has, without giving the exam away, because you can't do that unless you pass the course audit, I did a little breakdown of the problems on the 74 question exam. It was one of the Codeorg teachers who did it, and I'll share it in the document.
Yeah, please share that. I mean, I think that's exactly the kind of thing we want to be able to share. And if other people have done analysis, it'd be great. I imagine one could do an analysis if we looked at all the 96 questions that have been released by the College Board, what the coverage is. You can do all that kind of thing. And please feel free to share those things. Those are all public, and people can do all the analysis they want and share that as much as they can. Thank you for that. So let's jump on into the questions. There's 2 official sources of questions, the 22 that I've linked here from the original course and exam description on page 83. And I have that actually in another tab right here, so we can kind of look through some of these together. And the 74 that come from the practice exam. So please use that as a reference for your students and have them think about, oh, if I have this kind of question, you can imagine a variant that might be on another thing. So think about the kind of flavor of the question, the style of the questions. Those are pretty accurate for what you'll see on that. Obviously, no one wants to have surprises. And so those 96 questions are about 100 of the kind of thing you'll see on the actual exam. Obviously do know that there might be questions that aren't part of that 96, because Baker, you know that how many EKs are there? 300 and something? What was the actual number?
I lost count. 327, I think.
Right. So I mean, it's obvious that there are going to be questions that are not part of the 96 that have been released, but they should all be kind of in the same flavor and the same family. Nothing really that different, hopefully. So there are some unofficial sources of questions, and I'd love to have other people chime in whether they found these questions, these sources of questions, to be in the same family of these 96. I'll just talk about 3 of them really very briefly. There's a C-Engage book for about $20. So if you click on the link, you get it somehow. National Geographic Learning is the distributor for it, and C-Engage, and it's 1950. And I remember seeing some of the questions and some of them looked very good and very polished. Some of them looked like they could use some polish. So I'd love to have folks chime in whether they thought these questions were accurate and kind of close to the 96 people have seen. Albert.io is a site that I had never seen before, and it's a site that also has questions, and they cluster them by big ideas, and you can take them as an online experience and do this. And again, I haven't gone through the process, so I couldn't tell you how accurate they are, but people, your mileage may vary from any College Board official release set of questions. But again, these are people in the family trying to help teachers and trying to provide, and maybe some self-servingness to it, for you have to sign up and get access and pay some money for that. But hopefully this will help you get another set of questions. And finally, I was just by the Codeorg folks just today. I was pointed to a resource. They actually have a whole review course that they've put together, and so that's Codeorg. Usually costs money for a school, but this particular, a login is free for a teacher, and here's a set of questions, and I forget what I clicked on. I clicked on something, and here's a set of questions that look very much like College Board questions. And again, I can't say whether these are close, but you can take a look at these and see whether these feel like the same family of questions that the College Board releases. So I want to thank all three of those groups, the C-Engage folks, the Albert.io folks, and the Codeorg folks for releasing those questions, which is great. So folks, we're looking for the URL of this document. It's tinyurl/CSP webinar April 5. And please do feel free to, at the bottom, add any resources you have. I think Baker is going to add something to the bottom. So please, in the community resources, this is a living, breathing document. Add your stuff to it that you can. So thank you for that. Okay, let's jump on into some resources. So early on in the process, there was, and I'll scroll to, this is the CED, the course exam description. There's a reference sheet. So the reference sheet talks about, and I forget what page reference sheet is. I had this all queued up. But the reference sheet has a set of blocks that folks are responsible for on the exam. So here's a piece of code, and this code is now in block format. And some of the code looks like text. It kind of looks like Python-y text. It's its own language. It's brand new, and it's supposed to kind of share the idea that there are some common things in many of the languages. And so how do we show code if this is a language-agnostic exam? So in this reference sheet, folks said, boy, it would be nice if we had a living, breathing version of this, if we could actually play with this as a language. And then there was a fear that, well, if you build this, then it becomes really good. People will use that as their language. And we didn't want that. None of us on the development committee wanted there to be, an environment where the students sat in kind of the exam testing system. But it would be good to be able to play with kind of the blocks problems and robot problems and some of this. And there are some differences. I think Douglas is pointing out there's some differences between often many languages and the reference sheet. And so like equals is equality, not double equals, and so that's an issue. Lists are 0 indexed in many languages, but 1 indexed in this. So you want to make sure that those differences your students don't get tripped up on the exam. For the most part, no question depends on that. If you're going to look at the questions, you're not going to say, well, this question, if you had thought the question was 1 index, you get it wrong. As we're developing questions, we really try to filter out the questions that would have any difference about that. We were very clear about that, so that we didn't want to have the language issues be the reason someone got a question wrong. So I created a project in Snap that I believe looks just like you can live in the world of the reference sheets. I'll click on this, and the link for this is tinyurl.com/snapcsp. And Baker is right that there aren't going to be gotcha questions like that. And so here's your BootSnap. If you're not familiar with Snap, it's an in-the-browser environment. And here's the little screen. It's very much like Scratch, but it has some extra features. And here's a robot following the left edge of a maze doing something. And after it does this, and here's the goal. So black is a wall, white is an open spot. This is like an arrowhead, so you're facing the arrowhead. And when it gets to the goal, it makes a cat sound and does this. So it's always following the left edge. And so these are actually stolen from, I think I stole these from Codeorg's early maze problem. So I just stole the mazes and I put the mazes in, and the left edge solves it. So here's doing this. So let me just show you how this works and just give you a background of this. So in Snap, you have a green flag to start and red stop light to stop. So I push this to stop the project. And this is done in July 2015 as I scroll through. So at the beginning of one of the things from the reference sheet talks, maybe I should just find this reference sheet and find the place where I want to do this. Let me find the reference sheet here. All right, 114, sounds good. Oh, okay, perfect, beautiful. Okay, so let's jump right in. So, you know, one of the things that people were, they tried to make a simulation. It's like, how do I make this left arrow? How do I make a robot? How do I make this in a very seamless way? Well, one of the things that Snap allows you to do is put some characters in for, so Snap is a block-based language, and it lets you have spaces, and you know, has a space in the block name. Every block that's shaped like this puzzle piece is a command block. They snap together, as like these two blocks are snapped together. First, I added a couple blocks that are not on the reference sheet, so that just help with working with this. So this is you're kind of in robot mode here. If I click Reset Display, I clear it, and now I have a little cursor. It looks like I'm in a typing area. And if I want to use, if I want to just say Display Computer Science Principles, I click on this, and now it types Computer Science Principles, and it kind of wraps because there's a certain fixed width of this, and I want to have the font big enough to be able to see this. And if I keep doing this, it just works like you imagine kind of a printer do the right thing. I can reset the display, and that resets everything. In the variables, you want to be able to set a variable to an expression and then be able to reuse that. So in Snap, we had to kind of create two blocks for this. The first block, we call this the solid block. So the solid arrow is how you define a new variable. So I can, here's a variable. If I want to change the name, I click on this, and I change the name to be N or something. And N is going to get the name BJC. And then I can go over here and let's say I want to display that. So I can click here. I can now drag this out of that and drop it into a place I want to do, and now I'm going to display that. So let's say this works. I click on this, and I'm now setting N to BJC and displaying N. If I'd like to assign the value of N, you need the hollow arrow. This is just a little hack that we had to do because one of these blocks makes variables and one of them reassigns them. And to reassign it, you drag the N into that, and I say, no, actually it's CSP. And when I run this, I'm now typing CSP instead of BJC. So this is just a way that you can define a variable and then reassign it. There was not really a clean way to doing this other than having these two blocks for that. We have an input block that's mapped exactly like this input block, takes no inputs and returns a value. So if I were to say display the input, so I'm going to ask the user for it and then display it. So I click on this block. It's now in the bottom here asking me for this. I'm going to move the chat window. I'm going to type hello world, hello, and it's now typed the result of that. So the input's value was sent into that, which is quite nice. Again, these are blocks that I just gave for free. Reset a new line, put the cursor on the next line to use it. So if you're going to be doing some kind of text I/O, this is going to be the gray blocks are how you use those. And you can just create blocks by copying this. If you want to reuse this, you can right-click, which gives you a duplicate block, and you can kind of make different copies of that. If
can I ask a question about your code here is reminding me that
go ahead.
At some point from the pseudocode subset, they removed string manipulation functions, including like basic, in the subset here, there's no, it does not indicate how any kind of string concatenation would work. So, which means that you can't even simulate writing a program that like asks a person for their name and then says hello name. Will there be, like, typically you just use a plus to concatenate a string in a variable. Will questions like that appear in the exam and you're supposed to know what to do, or it's just avoided completely?
Yeah, sure. Well, I mean, again, there's some things I can't say about what will be on exam, what won't be, but in general, I'd say that whatever's on the reference sheet is all you need, and if there's ever a thing you wanted to do, they would introduce that for the problem. Part of the reason for having a reference sheet is if you don't have a reference sheet, then every single question has to contain a ton of reading about code. So by having a reference sheet, you kind of, it's like having a handout in advance. So you just know this, and you know that I'm going to be working with this, and then you can be practicing with it, and then every question can be really lightweight. The amount of reading, the amount of overhead for every student is much less. So I would just say if there is going to be a string question, they would kind of talk about, if we want to do the strings are useful. Here's a couple of string commands. They'd probably introduce them locally for that question if you needed it. That's what I'm saying. So all you need is this reference sheet, and if they want to do anything above and beyond that, they would teach you a new thing right there. Hope that helps to answer the question. But you still could do that with what exists now. You could ask for the name and display it twice. You could display hello and then another display the value of the input. So there's no reason you couldn't do. You don't have to have concatenation to be able to just keep spitting out things to the display to get interesting happening. So you don't need to worry. Students don't need to worry about what plus would do with strings as they have to in, say, Python and other languages. And if they ever needed to, it'd be explained on the question, if that helps. Okay, let's jump on back. In the reference sheet, there are operators. So the operators are classic operators, are arithmetic and numeric ones, mod and random. We have that here as well. But we try to model exactly that. Random has two numbers. The one thing about random is it's inclusive of the endpoint. So random 1, 3 could give 1, 2, or 3. So if I put a 1 here and a 3 here, and I clicked on this, this is a different shape. The shapes of blocks in Snap and Scratch are kind of puzzle pieced in this way when they're meant to stack together, and they're shaped kind of like ovals, and also for these relational operators like hexagons when they're meant to be kind of operations that nest. It can get composed about that. So here's 1, 2, and you eventually get a 3 out of it. There's a 3. Okay. Let's see. So here's the. And by the way, yes, Snap. If I ever wanted to type something into Snap, you don't need quotes around it. Everything is kind of just naturally a string, which works beautifully. You don't have to worry about the quotes and removing them and adding them. So the nice thing about Snap is you can actually add not equal to and greater than equal. So this is just literally maps 1-to-1 with all these relational Boolean operators as well, including not and an or. And there's a little difference in the shape, but that's just to kind of indicate that there are relational operators and Boolean operators. There's a little feature in Snap where you can drop these guys into each other. That's the normal way to do that. But you can also, if you want to kind of hard code one of these values to a true or false, you can just click on them, and the kind of checkbox is true and the X is false. So there's a way to kind of, here's the and of true and false, and that's going to be false. So that's just kind of a way to do that. I don't want to spend too much time on this. I want to get to the robot stuff quickly. We have selection operators. We have iteration. We have list operators, which is kind of a thing. And we try to, as much as possible, really model 1-to-1 with this. So list of I. So if I want to make a list, here's a way to make, here's the way to set 3 values and set it to a list value. So here's that same thing you saw before with making a new value. Here's data. I'll call it data. I can call it also, click it and say Dan's list. Dan's list. And it's nice we can have quotes in the name of things. You can't do that in most languages. Here's 1, 2, and foo. And now that's Dan's list. And if I wanted to now say for each of these items, in, now drag this here, in Dan's list, I could now do something with that. So that would be really useful. If I wanted to access a piece of that, so I would drag, here's the interesting thing, I drag Dan's list into here, because this icon indicates a list, and so this is like A, the array, and this is the index. So if I would say A of 2, if I were to set that, it wouldn't work here because Dan's list is a script variable. It only works for the life of this block. This doesn't just work independently out here. It's not a global variable, so this wouldn't work right now. But if somewhere in here I wanted to say, say Dan's list, I could grab that. Let's grab the display here and make a duplication of this and scroll down here. Let's do this and say display. And if I said Dan's list of 2, this would, in theory, would say, let's make it a 3. This is also 1 indexed, so this is 1, 2, 3. So this, in theory, should say foo, foo, foo. Let's see if this works. Foo, foo, foo. Aha, see? I could also say pull this out and say display the item, and this is a way to drag this over. And now, in theory, it should say 1, 2, foo, and there's 1, 2, foo. So here's just a way to kind of work with the list in there. So this is the way to kind of get the value of it. This maps to the list of I gets list of J. So you put a list here, you put a list here, and you put I and J, and it's the same exact idea. Here's insert, append, remove, and length, all exactly the same here. List, append, insert, append, and there's also for each. So all those live exactly as they do here. So all those are exactly the same. So now I'm past this, and I'm doing this great new stuff with the robots. I love the robot stuff, and I want to talk about the kind of the sexy part of this. So first I'm going to reset this. I scroll down to the reset, clear, draw grid, and put a robot in the middle. Okay? And now here's the coolest part. I spent the most time in this project doing this, so I'm kind of most excited about showing this demo. You can make your own robot problem. So you can click on the grid, and when you click on the grid, what happens is it makes a wall. And I'm just clicking making a wall. So I can do this and make a wall. And oh, I messed up here. This should have been an open spot. I click again, and it makes a goal. I click again, and it's a free slot. So I can very quickly make a robot problem. And so I can maybe make the goal here, put the goal there, and click around here, and do this. And now I've got this robot problem. And now I write some code that works on this robot problem. It's really very nice. If I want to test myself, by the way, I've mapped, I can show you this, I've mapped the up arrow, left arrow, right arrow to the rotate. So I can now, I'm now typing the arrow keys, and I'm moving, and I'm turning right, and I can be moving around, and I can go through walls. There's nothing stopping me going through walls, but the point is I can do this. Now the nice thing is there is a block that in the robot code at the bottom, you'll see here, there is a block in the robot code. Well, I want to get to how to make a procedure really quickly, but can move takes a direction. So we added the can move takes a direction. Here's the can move, and you ask it a direction. And so this is a way to kind of very quickly choose it. And what I did was, if you hit the down arrow, since really up, down, and up, left, and right are covered, what does down arrow do? Well, down arrow will tell you whether you can move in that direction. So I'm pushing down arrow, and it will bring up an array, a beautiful array, I shouldn't move too much, of testing around it saying, can I move? And yes, I can move forward and backward, but not left and right in this particular case. So it's kind of showing you all 4 can moves in one, which is kind of a nice little feature. Okay? So, okay, so let me just show you some interesting things. So one of the things I can do from this is I can, I've encoded in page 81, there was a robot problem. So if I can find my way to page 81 here, I think it's question 5. What I've done is I've taken the robot problems and I've put them in the bottom. So here's the CED question 5. It is all the released questions, right? This is all the publicly released in the CED 5, 8, 10, 14, and 17. And I'll just show you what this looks like. So here's, whoops, let me go to this. So here's question 5, which asks you, here's a robot using a grid of squares, starts here, it runs this piece of code, where does it go at the end? And students can now try to figure out and guess and run this slowly. So one of the nice things is Snap has the ability to slow things down. So I believe if I click this and I say visible stepping, I can now, here's a speedometer, and I can slow this down, and I can now run this, and if I click on this, this will reset the maze. I click on this, boink, it resets the maze and runs the little code. If I look in the question 5, I essentially, let me just stop this for a second, go edit, and this is the code. If you look back here, it says n is 3, repeat 3 times, repeat n times, rotate left, and n. So here's, n is 3, repeat 3 times, repeat n, rotate left, and change n. And this is all the blocks. So remember the solid to define n, and here's this empty one. And I just say clear. So I say clear, load the maze. So I've defined a couple of variables, which are these maze. I can take any maze you want, and I can save it to a variable, and I can then export that variable to a text file. I can import from a text file into the variable. I can make the variable by saying load maze. So it's a way to kind of, if you really want to do this and create some of these, you can do these with your students and create some more mazes and have some fun with that. One of the nice things about this is I can step. So if I actually were to click on this, in theory, I'm now stepping. If you watch this, I'm stepping through this, and Snap is visually showing you what's happening in each stage. It's decreasing n, it's going through, and it's still saying say answer from before, but notice it's actually following this in each step. So this visual stepping is really very useful for students who are debugging, and again, that's under the sprocket, visual stepping, and you're going to change the speed over here for how fast the stepping is. Okay? So unless there's any more questions, I'm done. I do want to show you really quick how to make a procedure. That's early on, you have to make a procedure. You can make one that either has a return value or just does something. And the way you do that in Snap, if you haven't done this, is you right-click in the background and you say make a block. And then the block, you choose the shape, you choose where it will live in this tab, and you use this. So I might make draw square without any arguments, but eventually I want to have some arguments. But then by moving my cursor to the end, there's a little plus sign, and I say the input, and I say the length. and here's the input step. So this is, you can't do this in the way that the blocks are. You have to kind of do this little snappy way of doing things. Anyway, this is a project. It's a gift to the community. Feel free to use this to share blocks and play with things and to explore. Here, if students say, I don't understand question 17, well, you can go 17 steps.
Sure.
You can.
So, Dan, you're sharing your screen. I don't know if you want to bring it up. I should preface this by saying that this is a complete hack that I hacked together because I was growing frustrated drawing pictures of code to put exams together for the Code.org curriculum. So APML is a language that I made up. It's called AP, Markup Language. Or I guess APBML, I don't know. It was late at night. The idea is that there's a very simple syntax, which is in the window or the little text area on the left that Dan is expanding right now. You can use symbols such as square brackets, which will give you a rounded rectangle. You can use pipe characters, which is the vertical bar that's right above the return key on your keyboard, to make a hard-edged square. And you can use parentheses to make an oval. With this markup language, you can compose blocks. So if you type, I don't know, Dan, if you want to type something in the box, it will render the block version of it in real time as you type. So this is useful if you want to compose your own block-based questions. It will auto-magically gray things that should be gray. It will auto-magically turn the arrow, you just type an angle bracket and a dash after it, it'll turn it into the little arrow symbol. Other than that, there's not much magic. You're on your own for indentation, and you can completely type incorrectly formatted block-based code. But it is a way, if you can type it out, it's a way to quickly make an image. And then as Dan showed, you can change the font size, and then the idea is you can just make a screen cap of the image that's rendered there and paste it into a test or onto your web page or whatever. I also...
Should you author in the pseudocode, you think, and then have it automatically convert to APML? I mean, if you code it in here, would it do the right thing? If I type this again, would it do the right thing in APML?
Absolutely not. What I should what I should probably do is actually get rid of the AP pseudocode button. That was another late night pipe dream that I said, oh, you could just type it in the text-based form. And then that ended up turning into, writing a language interpreter, which I didn't want. If you want to compose a text-based question, we all have text editors to do that in. The point here was like, how do I quickly make a drawing of the blocks without whipping out a drawing program and messing with pixel by pixel? So what it's actually, I should just remove. Go ahead.
Can you add a button here? Can you add a button that'll say whether this code will run forever or not? That'd be really great. If you could, that'd be great.
Yeah, if I could, I'd also be a millionaire. So stick to the APML version. I should get rid of the pseudocode.
Live in that world.
The point I'll make is that what it's really doing is just creating HTML with some simple CSS code to highlight it. And if you don't want an image, I also dump out the HTML that's there, or the HTML that it creates. So if you have a web page or something and want to copy and paste the HTML, I invented my own HTML blocks. So, yeah.
Great stuff. Thank you for that. That's wonderful. All right. So, again, these are all wonderful resources. We're all pouring into the community. Everyone can use them. They're all free. All those things are great. I wanted to share a couple of Codeorg resources. Maybe Baker, I pass it back to you to share one of these things. We pulled these up. We had a similar local webinar at Berkeley yesterday. We pulled these up, and I hadn't seen the Lossy one, which I loved. So you want to maybe talk through some of these? This is the widgets that you use. I think some of them are really delightful.
Does that take you to the...
Yep.
So
to the widgets page.
Yeah. So in the Codeorg curriculum, we often take an unplugged activity and then plug it in, and we do that with a widget. We call it our internal term for this is a widget, and so it usually is there's some problem context in which you're doing some sort of computational thinking thing to solve a problem. So Dan right now is looking at the text compression widget, which is in our curriculum, which lets you can load like a little poem or song lyrics from Aloe Black, who was very interested in this widget and like wanted to make a video about it, so we didn't stop him. And you can basically you look for patterns and you enter it in the dictionary and you try to see how much you can get the poem or song lyrics to compress, and it touches a lot of bases. It's not a specific essential knowledge statement in the framework, but there's a lot of like abstraction built in here and pattern recognition, and you can draw lines from what you're doing in this. There's also no algorithm to figure out what the optimal compression is. So we use this widget to talk about everything from heuristics to computationally hard problems to procedural abstraction. It covers a lot of bases.
So lossless compression. I love that part of this as well.
Yes, it's lossless compression.
And while we're here, let me just show you the Lossy one, which I love. Is this part of the official one? I just love this little app. So here's the Lossy one. And talk about this one.
So a little inside baseball about how the Codeorg curriculum is written. Baker gets some crazy ideas and writes them into an app in App Lab, and then starts hounding people to turn it into an official widget. This one didn't make it as an official widget, but it is an example of a form of Lossy compression where you type, Dan, if you're on it, you can actually type in it live.
I didn't realize that. That's really cool.
You can type in it live, and what it does is it removes all the vowels from the words. So a form of compression, of Lossy compression with text, is to remove a bunch of stuff. And so the sort of tongue-in-cheek question here is like, can you still read, could you uncompress this this text even though you're throwing information away?
And humans do it, right? I mean, computers couldn't because you wouldn't know what letter they are, but you might be able to based on n-grams or what word it might, probabilistically should it be kind of thing.
Right.
That's great.
So initially, yeah, it animates some text initially just so that you can see what it's doing, but you can type in your own.
So that I just thought that was a great example of Lossy versus loss. I really love those tools. How about the internet videos? You want to talk about those? I think those are a remarkable way to study for the internet. Big idea questions. Do you want to talk about some of these and how these came about?
Yeah, these internet videos, I would say they basically cover everything that you need to know about the internet for the AP exam. And we wrote the scripts for these kind of in one, it was one giant script. Like, here is the beginning of the internet and here is the end of what we need to teach. And so we also consulted the Purple Book. So like if there's, if you see animations or text on the screen, often that text is vocab that's pulled directly from the CS Principles framework. So these videos were made with the actual CS Principles course in mind. We wanted them to be generally useful to everybody, so there's no explicit direct reference to anything in the Codeorg curriculum in them. We just think that they're generally useful. So it starts with video one is like, how does a bit actually physically get from one place to another? That's a big problem to solve and is the basis of the internet. And then we cover a few other, we kind of group other internet topics together. We have some great presenters in here, including Vince Cerf, the actual father of the internet, explaining the protocol that he invented, the TCP/IP protocol. And my personal favorite video is the encryption and public keys one, which features actually a Berkeley student named Mia.
You weren't paid to say that.
I wasn't paid to say that, but the reason I know this Berkeley student is because I taught her when she was in high school, and she works for the Department of Defense on encryption. That's how she's paying her way through Berkeley, and she fell in love with encryption in a pilot CS Principles course. So yeah, so it's like the full everything coming home to roots. It's also a great synopsis of symmetric versus asymmetric encryption and how it works and why. So, yeah.
So I wanted to share that. I think that's probably the most significant resource that we use in BJC. I would say this is just too good to not use, so we certainly do. While we're on Big Idea 6, the internet, which I think is full of new terms that students don't know, I wanted to put a shout out to the Blown to Bits. It's a free book. They have an appendix, and their appendix is, they call it Chapter 10, but it's a delightful narrative way to talk about the history of the internet, and it's really, really accessible, and I would recommend it. It's just really nice to kind of provide a context for things, and they describe so many things that are also required in the EK, so that's a great resource for folks. Big Idea 7, there's a Teaching Global Impact NSF-funded project. So let me just bring it up really quickly, and this is a teacher-driven, this is all about CS Principles. This is about trying to gather together, many of us, Baker included, myself, and other folks who have NSF-funded projects, and even not, got together and try to pool our resources into one place. And so this is a great resource I wanted to share with you if you're teaching Big Idea 7 and looking for ideas for that. I know we're at the end of this, and I know you're probably all done with teaching Big Idea 7, but if you are still looking at that, and here's news to use, this is an updated page of Computing in the News that comes in, and so you can take a look at this, and it's curated, and these are like, they're pulling news and editing it every single, I think a couple times a week, and there's a lot of work that gets put in to bring these up, and these are all, this last week, interesting pieces of news that you can bring into your classroom, and this is great. Sean Morris, a local teacher at the Berkeley CSAF chapter, created a set of assessments and some resources, and he just shared it with us yesterday, and so I wanted to kind of share that. This normally would have lived in the bottom, but because he gave it to me officially, I wanted to be able to include it here. So here's a review and a key and assessments and slides from his trying to do Big Idea 6, the internet. So there's that. With 10 minutes left, I wanted to share some of the things. We made a pass on the EKs. And one of the things that I kind of did was I said, where is there a word that a student coming in doesn't know? And how could I try to explain it? If I said, Dan, what does this word mean? I try to explain that. So these are all the kind of hard words. This is kind of like doing a filter of the entire EK and categorized by big ideas. So in Big Idea 2, most of the words the students knew. These two words probably people hadn't seen before, overflow and round off. So this is kind of a way that I described it, and feel free to go in and correct it if you think that this isn't accurate. I think of overflow as when a car's odometer rolls over. You got maybe 6 or 5 digits, and if you go past 100,000 miles or 1,000,000 miles, if you have a lot of digits, it rolls over. Well, that's an error. You try to represent 1,000,000 miles, and it says 2 miles. So that's called an overflow error. And round off is when the number of bits you have isn't enough to represent a number that actually has more, should need more bits than that. So pi obviously is an infinite irrational. So any number of bits is going to have this round off error where you're stopping at some point. So in Big Idea 3, I found that lossy, lossless, and metadata were the 3 words that people hadn't seen. Baker and I just talked about lossy and lossless. Lossy is the idea that you lose some data to get really good compression, and JPEG images are a great example of that. Although I believe there's a setting in JPEGs where you can turn it down where JPEGs are lossless, but the average JPEG you're going to get is quite lossy. And lossless means that you can recover the original and PNG images that you might see are lossless. Although I'm also told there are lossy PNGs, but by default the average PNG is going to be lossless. And that's great. You can recover the original, but the compression is usually not as good as the lossy. And metadata is data about data. An example we always use is when you take a picture with a camera, you can often find in a little secret file, like an XML file or something, it'll tell you about the location where the picture was taken, or the aperture, or the lens.
Let me interject.
Or other things.
Yeah.
The lens that you use.
On lossy and lossless,
Baker,
and I think metadata, our video about images has those words on screen and talks about them in the context of images, like if you wanted a way to review or give something to pin to. I'll add all of these to the document. But
beautiful, love it. Thank you for that resource. Yeah, exactly. Add that to the thing, and we'll put it there. This is great. So in Big Idea 4, algorithms. There's more. There's quite a few more compared to 5, which only had one that I found. So 4 has a lot of ideas that students probably hadn't seen. In fact, I know PhD students that don't know the 3 words of sequencing, selection, or iteration. I mean, honestly. And one of them is talking right now. when I first got out, I didn't see this until we saw this in the CSP framework. Sequencing is code flows line by line in a kind of a one by one, like a recipe. Selection is use Booleans to choose a path. So you meet a man in the middle of the street and he says, do you want to go left or right? That's selection, and that usually manifests itself in if-then statements. And iteration is using kind of a looping control structure, and many of you have seen these before. Reasonable time and not reasonable time, these come from theoretical computer science and looking at orders of growth, often called big O notation, but that's watered down to CS principles, in which we talk about reasonable time being something that's polynomial. And again, even that's hard for people to understand what that means, but it means as the size of input grows, the number of steps, primitive steps taken, is a polynomial of the size of the input, and that means constant doesn't affect it at all, or linear, or quadratic, or cubic, or something like that. That's
do reasonable time and not reasonable time in the context of encryption and security, since most encryption algorithms are based on the fact that it's not reasonable. It takes an unreasonable amount of time to crack the key. I'm giving suggestions if people want things to latch on to.
No, great examples. As many examples as is helpful. That's wonderful. So not reasonable time means, as it says, you're not polynomial. That usually means exponential, the number of steps, like you're doubling every time your input grows by 1. And I didn't put an example, but if you wanted to kind of say how many teams would you have if you had this many NCAA basketball rounds? Well, if you have 1 round, you just have 2 teams. If you have 2 rounds, you have 4 teams, Final 4. 3 rounds, that's the Elite 8. 4 rounds is Sweet 16. You see how it's doubling every time? 6 rounds, you got 64. So that number is going to grow in an unreasonable way, and that's a great example of that. Heuristic is a way to say I've got a rule that guides my algorithm, and this is I think of it as I could do a maze finding algorithm, but I can also just always walk towards the North Star if I were stuck in a forest. Undecidability is a really, I'm just so proud of CS principles to include these really powerful ideas that don't even exist in A, but in CS principles, but in a way that kids can get it. And undecidability says that you can't create a solution that will work for all inputs, yes or no. And one of the examples that Rebecca and I were joking about earlier is determining whether any particular program on any particular input would always stop and not run forever. That's called the halting problem. You don't need to know that, but do know that there are problems that are undecidable, and that would happen to be an example of that. And there's one last feature, one last line on that, which talked about linear versus binary search. They may not know what those words mean, and so linear search means you go step by step looking for something as you would an unordered list of names. But if you had the list ordered, maybe you could start in the middle and then cut it in half every time. And you can do binary search only if it's sorted, so it's the usual thing. I found Big Idea 5 only had APIs as the word, and APIs really mean application program interface, and it's like how you define a library and call them. You might write a draw square program that's going to draw a particular square, and the input that you use might be the size of the square that you draw, and that's your interface. You're making an interface to that abstraction of the draw square block, and if you add more features, what color the font might be, and whether the dashed lines or not, that's more things you might add to the interface. And so the way people share software and the way people build software in library formats that can be called by others is by defining these APIs, these interfaces. I kind of took a pass on Big Idea 6 because it felt like every single one was a word that my students didn't know. I'll be very frank. And so again, thank you, Baker, for the Code.org internet videos. They're just really remarkable. Big Idea 7 had a lot of common sense things, but these words that I picked out were things that students may not have seen. Citizen science is asking the community to help a scientific project. Cloud computing is using distributed calculations and storage. People often forget the storage angle of cloud computing. Crowdsourcing is where you obviously crowdfunding. So asking the community to help with something and study at home to be able to search for signals is an example of crowdsourcing. Creative Commons is an alternative to copyright that lets people determine how you want to share their information, their creative works. Open access is a word that is applied to both libraries, traditional walk-in brick-and-mortar libraries, as well as digital resources like databases. That basically says things are open and you can grab access to that, which is just great. Moore's Law technically is the number of transistors on a chip that doubles every 18 months. It's often confused with performance and size of a hard drive doubling every 18 months as well, or doubling every 2 years. That's not traditionally Moore's Law, although in the vernacular it's thought of as Moore's Law, but just the idea that performance is increasing at an exponential rate is often what Moore's Law is called incorrectly. Peer-to-peer networks is the idea that you probably know this from Napster or something where you've got some files and I want to grab them, and rather than go through a centralized computer, your computer and my computer agree and you're the server and I'm the client and I just grab them directly from you. And digital divide is the final word that people hadn't seen maybe is that communities and resources have less access to computing and the resources within to be able to be online and to make use of that. Did you want to add anything, Baker, to my list? You may have lost him. Almost done. And let me close with the last couple seconds with tips for doing well, which is I would recommend your students do a ton of practice. You practice, practice, practice if you're going to be doing this. The vocabulary, as I said, hopefully this is useful to be able to kind of circle the things. I don't recommend having students read the EKs and study the EKs, but certainly if there are things that they didn't know, they could circle them and talk to you about them. And again, here's some general test-taking strategies of trying to cross off the wrong answers when they're obvious. Read the whole question before you begin. Don't get bogged down early. And finally, remember what section you're in. At some point, you're going to transition from choosing one to choosing two, and remember you're not just choosing one if you're choosing in the choosing two section. That hopefully should be pretty well spelled out on the actual exam, but just remember that if you only choose one out of the choosing two section, you won't get those questions right.
Hi.
Can
you hear me now?
Close it out, Baker, and do anything else?
Hello? Sorry, I was trying to talk before and it wasn't coming through. I wanted to make one final commentary about the sort of this list of things that's in the global impacts big idea. It feels like it is sort of a dumping ground for like, here's all like the new innovations that are happening. And it is kind of like a laundry list of those things. And so our recommendation, like not every curriculum is going to get into every single one of these things because each one is itself like a big topic. So I think sort of reviewing simple synopses of what these things are, like crowdsourcing, is a perfectly appropriate way to go. I just want to make the commentary that like, don't feel bad if you didn't like teach some deep thing about crowdsourcing. That's all.
Makes sense. That makes sense. And also remember, it's only 10% of the exam, so there's a little bit of like saving grace. If you haven't spent a lot of time on this, and your students really are weak in one particular area, hopefully everybody's strong in every area, but if they had to be weak in some areas, the ones that have fewer percentage of questions would be the ones, and the ones that perhaps are easier to answer if they hadn't, if they kind of have general ideas. Like a lot of these ideas, if you come in knowing these because of just whatever, then you're going to be well prepared to answer a question about them, right? That you come in with prior knowledge that does that. People may not have come in with prior knowledge about the internet. That's hard to get. But Big Idea 7, people often have come in with some of these examples. I'm done. I'm seeing some questions here. Baker posted the stats for the questions.
I posted a link. It's to a Google Sheet that I stuck right under
Oh, beautiful. Here we go.
and
Scrolling down.
stuff in the CB official, like, sources of questions.
Yep. I'm scrolling here. Here we go.
And I should, oh, Dan, you need to refresh your document.
Oh, is that right? Okay, weird. Why would it have frozen? It's kind of strange. I'm online.
I'll just tell people if they go through the breakdown, it was a curriculum writer and I at Codeorg went through the questions, and we kind of like tagged what we thought the topic of the question was and then matched it later to what the College Board flagged it as. And so you can see ones where the official tagging of it is algorithms, but it was listed, but we kind of gave it a programming and algorithms tag, which would be a clue about the formation of the question.
Good stuff. Good stuff. There's a question about BJC curriculum materials. I think the next year, I think one of the things they're working on for next year is to add more formal unit assessments in there. And these are written from people who hadn't seen the actual exam, so I'm not part of that family, but people who have not done that are going to put some questions together to help generate some of that. I didn't realize I was frozen, so, which I guess I was glad, because people, as I was scrolling through this, I would have seen a lot of clicks and cursors and all of that, so that was good, but it's funny that it all froze in my thing. I wonder if
I thought you did it on purpose.
I didn't. I don't know what happened. It was great, because I was like, hey, this is a nice, beautiful document. It looks beautiful. And now, I guess I was in view mode. Maybe that was part of it. I was in view mode, so it kind of froze and took a mini snapshot of it.
Yeah.
But anyway, a lot of people were talking and chatting. I really do thank all of you for your contributions. Again, this is supposed to be a living document. Please do contribute to this. And if you have other resources, other questions, add them to the unofficial list. If you have other things that kind of don't fall in here, here's some other things you've done. I think the reason this community is so great is because we're all sharing, and our goal of us is that we're not competing. We're trying to get all of our kids to the 5. So as much as we can, continue to try to share each other and ask questions and answer them together collectively. Thank you so much, folks.
Yes, thank you so much, everyone. Just a few closing things that I wanted to share with the group as the screen comes up here. We do have several other webinars this month if you're interested. Wanted to share that on April 11th. We're going to have a session about teaching the internet in a CSP classroom. So if that's something you're interested in learning more about, we encourage you to join us. On April the 18th, NC WIT is going to share information about their free programs and resources that they have available. And then finally on April 26th, Gail Chapman, who helped to organize the Exploring Computer Science curriculum and course, she's going to be here, and she's going to help talk about how to reflect on your year with lessons learned, etc. I'm posting in the chat window a link to our calendar on the CS for All website. If you will hold on to that, that's a great place for you to go so you can access how to log in for all of these webinars. And Betsy, to your question, we'll be updating the event post for this current one on April the 5th. That's where we add the recording, and we'll share the other resources that Dan and Baker
Bye,
put
everybody.
together.
Thank you.
So we'll
Thanks,
have a link
Melissa.
there
Thanks,
to
Baker. You guys are
the
great.
tiny URL
Yes, thank you, Melissa.
Google Doc that they've created, as well as the recording. But give us a day or so to get that together, and you can check back. So bookmark that space and visit it often. Thank you all so much, Dan and Baker especially, for being here with us tonight. Thank all of you for your wonderful questions, and best of luck to you of your students in just a very short